Welcome. This is SPSS, PSY 3840. Let's go to our assignments. And I'm Professor Fred Coolidge. We are up to Unit 6, Correlation and Regression. And what we're going to learn about is correlation and regression. And correlation and regression tells us the measure of a strength of a relationship between two variables. We're going to use the schizoid Asperger's controls data set again. And we're going to learn how to use probably the most popular test statistic ever created and ever used. And that's the Pearson product moment correlation coefficient between two variables. This correlation, measuring the strength of a relationship, this is the single most popularly used probably in the history of statistics. We're going to learn how to create a scatter plot of the two variables. We're going to learn how to interpret the significance of a correlation from the output in SPSS. And we're going to learn how to use the paste functions in SPSS rather than just going to the menu and asking it to run. We're going to learn to do paste and then run it from the paste function. And it just makes things a little bit easier for us. So let's go into our data and get started. And we're going to be interested. These autistic symptoms should be correlated with schizoid personality traits. These talk more about measured communication difficulties, nonverbal communication difficulties, shaking hands, things like that. These are more just simply being socially a loner. So it's very easy if we go to Analyze, and we go to Correlate, and we go to Bivariate, means two variables. And these were already clicked over. Let's click them back. So if we had our data here, we'd say, okay, let's do these two. So we'll click, highlight this one, move it over, highlight this one, and move it over. And we hit OK. We can see right here that the Pearson correlation between total autistic symptoms and schizoid personality disorder. And notice there are no overlapping items here. These are two different, completely different inventories. The correlation is 0.72. Correlations are usually reported just at 2 decimal places. And then right here we can see the significance. In a two-tailed test, we can see that P is equal to 0.000. And actually, we know that it looked at the 4th decimal place and rounded to 0. So the 4th decimal place must have been less than 5. So when we record the significance of this correlation coefficient, we have R equal 0.72, remember reported to 2 decimal places, and we could have put here P less than 0.0005 because we know it had to be less than 5, otherwise it would have rounded this one to 1. So we can also put, and this is unusual, more usual, P less than 0.001. Because if it's less than 0.005, we know it's P less than 0.001, which is good enough. And we see that we still have this data set where we eliminated one case, so the N is 70. This double asterisk also tells us the correlation is significant at P less than 0.01, but of course we got it much more exact here, so this is a little bit redundant. Let's exit out of here and say no. Do it again. Down to Correlate, Bivariate. We'll take the 2. And here we could have done a one-tailed test of significance. But I encourage all my students to run two-tailed, depending on how you've stated your alternative hypothesis to the null hypothesis. But we had flagged significant correlations. If we put that one off and we did OK, notice it got rid of the two asterisks that indicated P less than 0.01. Still, we had the default two-tailed test of significance, and we got that two-tailed test of significance. Again, we'll say exit out of here so it doesn't repeat it. And now let's go into Analyze. And now we want to do and learn how to do a scatter plot. Okay, so for scatter plot, we'll go to Graphs. We have to do it separately. We can't do it under Correlate. Would have been nice. but we don't have it. Go to Legacy Dialogs. Come down Legacy Dialogs down to Scatter dot plot. We have a bunch of different kinds of scatter plots we'll do. We'll take the simple scatter plot. Now we have to define the variables. Notice they're in there for us already. If they weren't, we could have said, okay, let's put schizoid on the y-axis and autistic symptoms on the x-axis, or vice versa. We were interested in their bivariate correlation. We didn't really have a direction. If we wanted to put a title here, which is handy, we could have labeled the top of this graph the schizoid and autistic symptoms scatter plot. Hit continue, hit OK. And now we can see that correlation, that 0.72 correlation. Remember in our lesson, you want the best fitting straight line. You can see that a best fitting straight line, it certainly wouldn't go this way. It's not negative. We can see it's positive. And it's probably going to be a good slope here, because that correlation of 0.72 would give us a nice slope. So now to fit the best fitting line, we'll double click on it. It brings up this chart editor. We'll go right to here and add fit line at total. We'll close this window that popped up, and we can see that it gave us that best fitting line coming across. Pretty good slope. If it had been actually right from here right to here, it would have been a correlation of 1. So this is a little bit flatter slope. And this r squared, actually, if we took the square root of r squared and gave us r, we'd get the correlation of 0.72, just like we saw earlier when we did the bivariate correlation. But this is the square of that, and so to get the r, this r squared then means this is going to be interpreted as the percentage of variance of this variable and this variable. And it's saying, if we looked at them as two Venn diagrams, they're overlapping about 50%. And that's that correlation, r, of 0.72. Now we'll get out of here, and we'll get out of here, and we've got one more thing to do, and that's the paste function. So we'll go to Analyze, we'll go to Correlate, and we're going to need the correlate when we, or the paste function. Let's move these back over, start again. If we've got 3 variables, let's put in age, autistic symptoms, and schizoid. Okay, we've already done autistic with schizoid. So, and we could just hit OK, and we get the correlation matrix. In fact, we'll do that, of all 3. So now we've got age with autistic symptoms, age with schizoid. Autistic symptoms, remember with schizoid, was 0.72. Autistic symptoms with age, so we're going to get some information repeated here, or redundant to these 3 unique correlations. But let's say I just wanted age with autistic symptoms and age with schizoid personality disorder, but I didn't need to see autistic symptoms with schizoid. Perhaps because I've already done it, perhaps because I didn't need it. So let's hit no on this output. Go back into Analyze, Correlate, Bivariate. All 3 were over there. It kept that. Now go to Paste. And this will actually show us the syntax that SPSS uses to create that two-tailed test and deal with any missing values. So if we put right here and type in with, age with these 2, it won't give us the correlation of these 2. It'll give us the correlation of this one with this one, and this one with this one. We hit Run. And now you see it just did age with autistic symptoms. There's little or no correlation. And age with schizoid personality disorder. And there's little or no correlation. And you've seen this one's a non-significant correlation. It's so weak. And this is also a non-significant correlation. It's so weak. And that's how we use the paste function to get us to get rid of data that we really didn't need, or to get rid of all this extraneous information. And that's our lesson for today.